my own name is Tamsin. I'm Professor of Sustainable Business and the Research Director of the new Center for Sustainable Business. And one of my little hobby horses is what we call digital sustainability in my field. This topic, basically. How do companies, in my case companies, deal with AI, both as a solution for many problems that we have out there, for example climate change, but at the same time, are we not asking for trouble? What is AI doing, and is it not creating problems in and of itself? So I asked the panel members to discuss from their respective fields how they look at this. And I asked them to think about the good, we only start positive, the bad, we go a little bit negative, and then we get to the ugly. And this is where we're ready for the drinks. No, there are no drinks. It's that ugly. So when they really seem very optimistic, that's because I asked them to be optimistic, and I asked them to be a bit pessimistic towards the end. At the end, they might say where they really feel where they are. But we feel that there are these different sides to it, which comes back in many of the different things here at the Festival of AI. AI is something that we discuss a lot because of the conflicting views on it. So, what are the good things? The good things, of course, is this digital technologies and also artificial intelligence help us make lots of decisions, help us manage everything out there. And with big crises like the climate crisis, this is needed. If we, for example, want to have green energy, we have solar panels, we have windmills, they create energy in different places, but how do you manage such a network? You can't do that without digital technologies, that's everywhere. So it is really becoming part of the whole green economy and trying to address net zero. People talk about things like blockchain technology as well to do fair trade and to figure out, okay, where are our products actually coming from? But there are also some bad sides of it, because we might use it as a solution for sustainability challenges, but at the same time we're using something that uses a lot of energy, we know. To even just train large language models, generative AI, that just uses a lot of energy. Then we talk about bias all the time. There are many new social issues popping up because of that. So, on balance, where are we then? Are we not basically using it as a solution while creating bigger problems? And then, what is the ugly? The ugly is that a lot of how we use AI is not to come up with solutions for sustainability problems, but to do whatever with AI. Most of you will be using AI, I don't know, to predict better what kind of music you like, to find a better training plan. I don't know what you use it for, it's everywhere. So it's booming like that. So all the potential problems of AI can really fast spin out of control from a sustainability perspective. And I also really think about social issues, privacy, what happens to our data. So there's so many different facets. We have 4 panelists here, all professor, so they should know about their topics, but from very different fields. Yeah, now they're like, oh, they did prepare, I asked them to prepare, so they have pieces of paper there, no slides. We first have Professor Christer Hogstrand. And he is, well, he has lots of different backgrounds, but currently works in the School of Cancer and Pharmaceutical Sciences, where he's the head of the Department of Analytical, Environmental and Forensic Sciences. That sounds in and of itself already quite like, well, there's a lot to talk about, and I only gave him 5 minutes, so let's see. Then we have Professor Tamsin Edwards, who's a climate scientist, so it really comes from that. There are lots of additional information, very active in the political field, I would say. So has a good idea about how this can be used for climate change, but also the potential problems from a public policy perspective. Then we have Professor Frans Berkhout, who is the Assistant Principal for King's Climate and Sustainability. So that is the main sustainability initiative here at King's, and also Professor of Environment, Society and Climate in the Department of Geography. And comes from a, I would say, sustainability transitions perspective a little bit. This is how, at least how I know your work for quite some time now. And then we have Professor Moreau, who is Professor of Computer Science and Head of the Department of Informatics. And he's renowned for his work on provenance. And he explained to me once what it all is, and I forgot again, so he will explain it probably again. I I then realized I'm not a computer scientist, and it went just like that again. Quite complex stuff, but you see why it's relevant here for a discussion about AI. So I asked them to, in about 5 minutes, give their perspective from their field of what they think is the good of AI for sustainability, and then we'll develop more towards the bad and finish maybe with the ugly. But then we'll open it up, and we'd love to hear from you as well, where you see promise, but also where you have concerns. So I'm just following the order like this because that is easiest. So Christer, if you like to start, and if you want to use the microphone, I have to first unmute.
Okay. Is that better? So thank you, Jonathan. And so I'm going to talk to you about chemicals today. So chemicals are essential to our well-being as part of our time as after industrialization, and basically to have the modern life that we have, anything from industrial chemicals to drugs. And humans have made about 100 million chemicals. Most of these sit only in laboratories, but 100,000 of them are currently on the market in Europe. And here comes, and I'm going to break initially my directions here, because here comes the ugly. The ugly is not the AI in this case. The ugly is the present reality. 80% of those chemicals have never ever been tested for safety to humans, to the environment, or to anything else. 80% of them. And we're creating and marketing, or there's 2,000 new chemicals registered in Europe every single year. And they eventually end up in the environment, many of them. To assess the safety of these chemicals take around 5 to 10 years for each chemical. And remember now we have 80,000 of them that haven't been tested at all. The cost of doing that is for an industrial chemical, or non-pharmaceuticals I should say, is around 1 to 10 million per chemical. For pharmaceuticals it's small, because they have to pass special tests, because they're designed to have activity in our bodies. So to be able to establish that a pharmaceutical is safe, it costs between 80 and 800 million. And that's why part of why drugs are so expensive. So what do we do? Well, I come to the good. What if we could, instead of actually doing all these experiments, which also cost a lot of money and also waste a lot of animals in the testing that is currently done, what if we could predict what the chemicals are doing based on their structure and our past knowledge of activity in organisms? There are some old professors that you meet every once in a while that in toxicology you can just look at a chemical and they will say, oh, that will definitely have effect on the reproduction or immune system or nervous system. They can't really tell you why, but they have a hint somewhere, a way that they really can't tell it. They just know by looking at this chemical, obviously its structure, and comparing it with the past knowledge that they have on how similar chemicals do or reactive groups that they might have to do. Now, we're really lucky because we have one of those professors in my lab. It's called AI. And so what we're trying to do is to train AI or neural network to do what that professor is doing, to recognize the features and properties and structures and reactive groups of chemicals and use that to predict what kind of effects that they will have on you or the environment. I have, for example, a very clever PhD student, Alexander Kalyan, who's been able to create a neural network that can predict with 80% accuracy if a chemical will be mutagenic or not, and therefore cause cancer. And that's actually as good or even better than what you can do with an actual experiment. That's quite astonishing, isn't it? So, using AI-based predictions of chemical toxicity then will possibly give us a chance to catch up with all those 80,000 chemicals and be able to handle those 2,000 new chemicals that have been registered every year. And most importantly, make sure that chemicals that are bound to be bad for you are never produced in the first place. So they get stopped already at the drawing board. So the bad then, well, this is all based on that you are training these systems or predictors or machine learning on something that we know from the past. So comparing effects to the chemical structures that we have. So we can predict the known unknown, as it were. But what happens when the unpredictable occurs? A classic example of that is, of course, thalidomide, which was registered only for 3 years in the UK. And during those 3 years, it resulted in 2,000 children being born with severe deformities. We don't want that to happen. They couldn't do anything about it. They didn't know it at the time. They could not predict it. At that time also, type of testing of pharmaceuticals was not really based on mechanistic function or mechanistic knowledge, but more just like you test it in animals to see what happened. And they simply did not have the tests in place that would enable them to pick up the quite extraordinary and unusual features that thalidomide did and had to cause those deformities in babies. So what happened then when something like this pops up again, because sooner or later a new thalidomide will occur? Well, in terms of animal testing, we have learned that we now have new systems in place that will allow to catch that kind of effects, and most effects. But we want to use AI, and we have to use AI because, as I said, we cannot test them all. And what happens when we have to predict the unknown, and that is the bad with the AI. Thank you.
Tamsin.
Thanks. Yeah, we're too many glasses and not enough microphones. So I'm going to talk about 2 examples, and forgive me under the heading of the good for the first example being my own research. But I want to talk about it because it informs some of my perspectives on, I guess, the concerns I have later in the panel discussion. And also, I suppose, to highlight the fact that there are lots of people who have worked in the field of AI for a while without calling it that, and I was definitely one of those. So I come from a background of quantifying uncertainties in the predictions of computer models, especially computationally expensive computer models, of which climate models definitely are an example. And so what I'm interested in is how confident are we in climate model predictions? How can we evaluate those with data? How can we estimate the errors or the error bars in our future predictions? And I mostly work in the particular area of what's the response of the ice sheets, the Greenland and Antarctic ice sheets, and the glaciers of the world to climate change. How quickly will they melt and contribute to sea level rise, affect the water supply in mountain areas of the world? And those models actually, they kind of stand alone from global climate models. They're a bit simpler, they're a lot simpler than global climate models. They're faster to run, they have fewer inputs and outputs. But it's still a relatively complex problem to think about. And in that field, they've been thinking more and more about uncertainties and how to think about how to estimate those in recent years. And so in my work, I use a kind of machine learning called Gaussian process regression, but as I say, I always used to call it just quantifying uncertainties, or emulation. It's used in my field. Meta-modeling is another thing where you're basically trying to mimic your complex computer model. You're trying to learn its behaviour when you change some inputs and go to different outputs. What were those different relationships, so that you can then predict what your climate model or your Antarctic ice sheet model would say for any set of inputs. You can sample every possible plausible set of inputs and come up with probability distributions for the future, for sea level contribution, say, from Antarctica. And so I guess the point I wanted to make there is this Gaussian process type of machine learning. The reason it's very, very prevalent in the field of uncertainty quantification for computer models is it comes up with uncertainty estimates about its own predictions. So when it says, I think your climate model will say this, if you run it with these input values, it gives an error bar on that. And that's incredibly important information for testing whether your emulator, your machine learning is overconfident or underconfident, as well as just looking at the simple biases. And you can wrap that uncertainty into your predictions. There are more and more people using this kind of approach, and what was nice is I went to a conference called Climate Informatics recently with another friend of mine who uses these methods, and we were a bit worried we'd be seen as dinosaurs in the kind of machine learning and AI field where everybody's loving to use neural networks and all kinds of fancy new combinations of things. We were relieved to see that the Gaussian process still exists, but I'll come back to that uncertainty point in the main panel. One really nice talk I saw at the conference was by Elon Price from DeepMind, from Google DeepMind, who gave us some hot off the press results, the latest results for their weather forecasting model. So obviously weather very related to climate modelling. Called GenCast. And GenCast is a generative diffusion model, so it generates new data, has this diffusion aspect, which is very similar to when you are working with images. If you go from text to image, text to video, image search, this is the kind of thing that's very often used. And they trained it on about 45 years of effectively weather data, global weather data, really just a handful of variables, and basically they could, given 2 time steps, 12 hours apart, they could then make a weather forecast for the next 2 weeks. So going kind of step by step. And they were finding that now they can actually beat the physics-based weather model. So, for example, the Met Office. It's probabilistic, it gives uncertainty estimates. And sort of crucially, better than a couple of the other machine learning weather forecasting models that are around, it didn't just beat it on the simple metrics, kind of error metrics, but it really looked realistic. So it was what they called sharp, it wasn't kind of blurry, and it really looked like weather in a way that previous models hadn't done. There was a nice talk titled talking about the early results of GenCast I saw, which was, they were published on the 23rd of December last year, and someone called their talk, how to ruin a numerical weather forecaster's Christmas. So just to wrap up, clearly, a machine learning model like that, once it's trained, which is a bit expensive, it will be very, very fast to run. He said it took 8 minutes to generate an ensemble forecast, compared with the big supercomputing of the Met Office. And that was a global 0.25 degree resolution, latitude and longitude resolution. And clearly that's going to be saving energy in computing and also open up accessibility of that weather forecasting capacity to countries that can't afford state-of-the-art physical models and supercomputers. So that's definitely a potential for good, and we can examine a bit more later, I think.
Okay, thank you very much.
Great. Well, I confess I don't really use AI at all in my research, so I'm going to talk a little bit more historically about what we know about broadly information technology and sustainability and how that debate has, I suppose, developed since the 1990s and where we might be today. So broadly, the debate about digitization and virtualization, the academic debate about that really goes back to the late 1980s, early 1990s. And what people were fascinated with then was the substitution of what was called bits by bytes. I'm sure you've heard all of that before. And the technical and social science literature on that argued that there were 3 orders of effect that you would expect to see. And the first order effect is the power and resource use associated with the devices that we were going to be using, so the direct uses. The second order effects were to do with the resources that went into those devices and the wastes that emerged from them, electronic waste and so on. And the third order effects were the broader effects in the economy that IT, as it embedded itself in all aspects of production and consumption, was stimulating new forms of production and consumption, enabling global supply chains to be articulated in much more efficient and reliable ways, stimulating consumption, people shopping online and so on is only possible once you have an internet connection and a device and so on. But also countervailing effects in productivity. So the use of these technologies clearly stimulated huge efficiency improvements in many industries, both production and service industries. So all of these effects together, primary, secondary and tertiary effects, were complex, they were difficult to disentangle. But I think the point about it was that although there was this initial great enthusiasm about virtualization, bits turning into bytes, apparently becoming disembodied, actually there was always a very important material aspect to the information economy as it emerged. Now it seems to me that applying those rather simple insights to the revolution we're now seeing with generative AI is that we seem to be entering a qualitatively new phase in this relationship between technology and resource use and sustainability. As generative AI moves into broader implementation and adoption, and we expect it to have transformative effects in economies and in all sorts of patterns of behaviour and the way we think of ourselves. So we read daily about the power use has already been mentioned, data centres globally, the latest IEA report, energy consumption forecast to double between 2022 and 2026 to 1,000 terawatt hours, which is equivalent to, so this is data centres equivalent to the energy consumption of Japan, for instance, by 2027. Power use of AI alone, one projection done at the end of last year at the Free University of Amsterdam will be equivalent to the power consumption of the Netherlands. So these are absolutely gigantic numbers. We saw Microsoft's new report this week, I think, showing that although they've got tough sustainability objectives, actually their Scope 3 emissions have jumped as a result of the use of AI and particularly research as well. So what we see, I think, in this new phase of development are clearly multiples of, it multiplies manyfold the resource use implied by technology. And I think what we're also beginning to see much more is a concern about water use. So it's not just energy, it's really to do with water use actually being tremendously expanded by the use of AI. It clearly, so those are first order effects. Second order effects, it clearly accelerates demand for chips, devices, and all sorts of new infrastructure. So you have a profound acceleration of these second order effects. And these third order effects, the wider effects, the potential for revolutionising many sectors in the economy, clearly that's there, and that's very much in the expectations as well. Growth rates, economic growth rates worldwide are expected to increase as a result of the adoption, the widespread adoption of AI. I think there's a fourth fascinating element here as well, is that AI as itself an autonomous user of resources, as AIs become themselves a sort of separate economy, as it were, making decisions and choices. It's not just people, but it's AIs themselves that become generators of demand and waste and so on. I think that's a whole new fascinating area that we're just beginning to see. Of course, there are many uncertainties, and there's a huge lack of good data, and we still don't really understand at all what the broader productivity effects will be of generative AI across the economy. There are widely differing expectations and forecasts of that. Typically, I have to say that in the history of technology, technologies tend to actually take far longer to have really revolutionary effects than one expects at the first outing. So I suspect that that will be the case with generative AI, even though we're all very excited today. In 10 years' time, when we look back, we might actually wonder whether the transformative effects we expected actually have taken place. So I think a note of caution, and certainly looking right across economic history, that has been the experience. But there's also very much, I think, in what I've said and what the current tenor of the debate is, the view that the current trajectory of growth of AI is actually fundamentally unsustainable, and that there may in fact be a basic design flaw in the way large language models are set up and the way they actually do their work. And there are many people, including at King's, who are beginning to question whether that way of doing AI is actually at all the future. We need to be thinking much more about ways of doing intelligence, synthetic intelligence, that is much more learning from the way the human brain works, which of course is far more energy efficient, works in different ways, and perhaps we're actually going down a bit of a dead end. I know that seems like an extraordinary thing to say, particularly from someone who knows nothing about AI, but there's that sense. And also the sense that actually resource use, energy demand, water demand, represents a really very significant constraint on the deployment of generative AI as it's currently conceived. So a real challenge actually to the viability of that way of doing things. Now clearly there are all sorts of activities going on. I noticed doing some little bit of background research for this short intervention that the ISO standards for sustainable AI will be coming out later this year, so there's a lot of activity, a lot of awareness of this in the sector. But I think there are really profound challenges actually to the trajectory of change and the real concern whether actually we're generating problems that will be very, very serious. Thanks.
And that was the good part. So, as a computer scientist at this level, on the one hand, I want to defend technology, and technology really brings something totally new. It's through computing, and I don't tend to think in terms of AI, but more in terms of automation. We can capture data better, we can be systematic, and then there are lots of algorithms and analytics techniques that are being developed, and they allow us to predict, to have better predictions. They also allow us to monitor what's happening and potentially have real-time interventions. And wouldn't it be good if we had real-time interventions when water companies are throwing their pollution in rivers, okay, as an example. Of course, the world is not as rosy as that. First, we cannot capture everything, we cannot record every single data. So we have to work with partial knowledge or partial data. And then comes the elements of uncertainty that we spoke about earlier. But increasingly, methods are being developed for that, and in particular in universities. I believe that universities have really a place in terms of research to develop new techniques to address that. But also, it's even though I'm a technologist, I don't believe that technology is the only solution. It's also a social problem. Even though we've got the techniques, actually we don't necessarily use them adequately in order to capture the relevant data that would help us reason. So we've got certainly something to do here in terms of education, and that's again something that as universities we have to do something about in our teaching, and we introduce sustainability, for instance, in a curriculum across King's, and that's something that is very important. In my department, we're trying to appoint a chair in computational sustainability so that we look at that dimension. But also, that comes with lots of problems, this whole monitoring and this capture of data. We could imagine that we reach a point, and potentially some societies are doing that already, where we are totally monitored and we measure our CO2 emissions. So what's the implication for society, for privacy, to be monitored like that, okay? Also, societal change and behavior change is required, and that's something that we have a role to play there, and again, education is very important for that. We come to the ugly side, and actually Frans has already said a lot, so I'm not going to repeat what he said, but I like to see, we used to say that the IT sector is a clean sector compared to transport, for instance, or energy, and when the reality is that it's a hallucination, if you allow me to use this term in this context. Also, we say that AI is a black box because we don't understand its decisions. It's also a black box because we don't understand its energy consumption. Actually, I've been speaking to colleagues about ChatGPT, the resourcing, and this is really an unknown. We really don't know what's happening there. We know what we are being built in France, but we don't know the CO2 emission really there. And then there is the ugly side, I would say. And I find we tend to, we're looking for scapegoats, and the first scapegoat is the poor cows that are being accused of farting and causing so much emission. Okay.
It's true.
But also, no, I agree that the data centers have got terrible effect on the environment. Okay, but we also have to understand why this is like that. It's a response to the demand. And the demand is us consuming, okay? It's us liking the convenience of watching Netflix instead of going to a store to rent a VHS tape, as in the old days. No, but the convenience that we have has got a really strong implication on all those data centers, okay? And therefore, the impact on the environment.
So they were supposed to only talk about the good, but they couldn't help themselves. They was going to bad. Thank you. The only person can be. So my first question is, what is the ugly side of climate science?
Well, maybe I can just very quickly go through my tick list, and then I'm sure people have already touched on some of them. You talked about the black box aspect of AI, and I think this relates to the uncertainty quantification. I think what worries me is I'm increasingly going to conferences, maybe geoscience and climate conferences, cryosphere conferences where I work, and seeing particularly early career researchers, because they're more likely to dive into using techniques, but also more senior researchers, kind of just picking these tools up and not always seeming to have a very clear idea of how they would choose a particular one tool over another. And I think I see, I've talked about the sort of advantage of the methods that I use, and mine aren't the only ones to have uncertainty estimates, but I do often see people picking up and using whatever they can get to work, or whatever their supervisor told them to perhaps initially, and not trying to explore other possibilities. And I think, or whichever perhaps satisfies a particular metric, it seems to work the best. Sometimes they come back and find very traditional statistical methods work better. And I think that kind of brings me back then to the kind of, I think we need clearer thinking on the concepts a lot of this stuff. Why do we use a particular technique? And what is actually new about it? So I'm still kind of
mapping out the landscape, I guess, of like different AI techniques myself. But I'm yet to be convinced that there's anything like conceptually new here, right? It feels to me, I'd be interested to hear if someone does have an argument for this. I've yet to hear anything that convinces me that it isn't essentially a rapid acceleration and an extension of complexity and capacity of things that we've been doing for a while that will continue, and actually what we call AI or what we call like the new exciting, this is something brand new, is effectively what we don't, what is new to us and feels like magic. And Netflix does feel like it is magic if you imagine taking it back to someone from the 1950s, moving pictures and streaming to you instantaneously, and and actually we're just used to that. But I think that's important in the sense of kind of ethics and sustainability, because it allows people to sort of pull the wool over people's eyes. I think there's a great amount of hype and overselling of the newness and novelty, over-promising, and I feel kind of related to what Frans said, that this is a bubble forming, that we're going to see some big mistakes and some quite serious consequences, I would think, in the next few years as people kind of reach beyond the limits of, I guess, their knowledge. And one example of that actually was that Ilan Price talk about DeepMind's Gemcast that I mentioned. Because he said, oh, well, we've only got 40 years, 45 years of this weather data, so we can't really test how well this is predicting extremes. 99th percentile heat waves and things. And of course, that's the stuff we care most about in society, is the extremes. And I said, oh, well, couldn't you just train it on climate model data to see how well it gets the extremes in climate models? Because we've got, thousands and thousands of years of climate simulations. And he said, oh, I hadn't thought of that. Right? And this is a team of like maybe 10 people in DeepMind, and they don't have the domain knowledge and they don't have the domain connections because they're in a corporate environment. And I'm not saying, he's obviously coming to conferences, I don't mean to doom down too much, but I worry that this is like this kind of, this leads me on to the third point. When we've got corporations taking this stuff because they have, as we heard at the reception last night, Google's budget for development is bigger than the entire UK research budget and this kind of thing. That that the algorithm specialists and all the data center owners run away with this stuff, and first of all don't necessarily have the domain knowledge and breadth and connections of the academic and university knowledge landscape, but also might get bored and drop it, right? I can't see how DeepMind are really going to be interested in operational weather forecasting for the next 50 years, right? They want to make the coolest, fastest, best model right now. Are they just going to drop it? What happens to it then? Who takes it on? Will they let anyone take it on? So there's my list.
Yeah, we captured that with the term called generativity. And once it's out there, it can be used by anyone, but not necessarily for the intended purpose, and you never really know, and then what happens with it. And that's also the beauty of it, but it's also the ugly side. So we've heard good things, bad things, and we're undecided. So we would like to hear from you what your questions are, how you view these things. Keep it fairly brief, because the whole session is 3 hours. Yes.
Oh, thank you.
There is a microphone coming.
Thank you. When we talk about opportunities and challenges on any topic, it's essentially both sides of a coin. So, how do you see that it's about regulating or basically making sure that the opportunities are harnessed while the risks are managed? So, how do you see in future that the evil effects or bad effects of AI or computing per se are managed well? Because it's going to come. We can't stop it. It's going to come out. And basically, if we don't manage it, it's a problem. So do you see any frameworks or any approach to control it, manage it, so that it does not have adverse effects on sustainability altogether?
Anyone wants to have a go? Yeah.
We don't. Sorry. Thank you. We don't have the answers at the moment, okay? And that's very much a research question. And actually, at King's and many universities, we are studying responsible AI. There are research projects trying to understand what it means to develop solutions responsibly. Detecting whether a drug is safe also allows you to detect if a chemical is unsafe and could be used badly. Okay, so the question is, when you develop those methods, how do you make them available? How do you release them? And we are developing not only the technical solutions, but the socio-technical solutions, because governance comes into play, regulations as well, and good practice, and all that needs to be disseminated to the younger generations, to students that we train.
So yeah, I think there are lots of things that can happen, and typically when you have a new technology, you know, the institutional environment needs to adjust to it. And the first thing we need is transparency, of course, and understanding of actually what are the impacts, particularly to do with energy and now water. As Luke said, actually, we don't know when we train a large language model on a data set. We don't really know. I mean, there have been various assessments done going back quite a while already on these things, but actually, do we trust them and so on. So I think there will need to be some standards about reporting where people have really done the work properly, and that you would, as a user, be given some information. Transparency is very, very important, and then there'll be, you know, a need for users to adjust. I think secondly, you then have the emergence of standards, of new kinds of standards. So the ISO standards, which are coming this year, are just the first set of standards, and there will be all sorts of other standards that are used within industry, that are developed by consumer organisations, by, you know, third-party environmental organisations and so on, who will argue that certain kinds of applications are no longer justifiable or responsible, and you really should be doing it this way, and, you know, and so on. So I think all of that will emerge, and then gradually you'll have regulation emerging as well, particularly around the more massive energy and material side of this whole enormous and exploding industry. You know, we've had many regulations around electronic waste in Europe for the last 20, 25 years. Actually incredibly ineffective. Producer responsibility, all these kinds of things haven't really been implemented properly. And it seems to me very likely that as these problems mount, the need for much tougher regulation actually, you know, properly implemented, with costs falling on people that are, you know, penalising, that you will then get a drive to innovation. But as I was implying, and I'm sorry I'm not a technical person at all, I suspect at the heart of this will be really a look at the algorithm itself and the way that that machine works, because you can't boil the ocean in order to deliver AI applications. That's never going to happen. And so actually there's a really quite a profound technological challenge, it seems to me, to find ways of doing the learning that isn't, and the searches so that, you know, the applications are being applied in efficient ways, that isn't so penalising on the environment.
Just add really shortly. So, I mean, mentioned already that transparency is a big component of it, and coming up with ways to prevent AI from hallucinating is another one. But there are algorithms and technologies that will help us or the public to gain more confidence in what comes up, like explainable AI, for example, which is not one technology, but a series of them. But I think that's really important, because what you want to avoid is that black box that just tells you the computer says no, the computer says yes. Right? So yeah, so explainable AI probably should be expanded further to gain public confidence in it.
I'm Kirsten McEwen. I'm a MSc student here studying ESG management. My question sort of bounces off what Tamsin said about people diving in without really thinking it through, but also now a little bit about Chris's point on explainable AI. And it largely comes down to those sort of safety and alignment issues that we're seeing. And definitely AI is moving at a fast pace. And, I mean, I'm not even going to talk about like bad actors or AI going rogue, but more the sort of human error, AI / to human communications where it misunderstands what we want it to be doing, or biases from data sets. And I'm sort of wondering whether or not there are any kind of particular things you're worried about in your various fields, or particular things that you think we as people interested in sustainability should be doing more to try and influence. And the one that springs to mind for me is sort of from a business, maybe political perspective about, the fact that climate hasn't been prioritized until fairly recently, and the effects of climate are not going to reflect what happened in the past. So the data we have from the past is, maybe going to have some problems then if we use that to build future decisions. But is there anything that you think, particularly from that sort of safety alignment perspective, you would sort of, I guess, push or?
I guess I can give a perspective from like one layer back, because so when I started out as a postdoc researcher, I was learning about how to think about uncertainties for the global climate models, and then I moved into the field of ice sheet modelling, and then more recently glaciers. And there's a very analogous thing with what you're talking about with the uncertainty estimates, where people were using in this field physical models as kind of truth. They'd be like, well, I'm tuning my inputs to match the data as best I can, I make a prediction, that one number, that one trajectory is my prediction, that's the best I can do, don't come along and tell me to do anything differently, basically. And I've spent my whole career basically persuading people to try different inputs and allow that kind of detuning and like critical evaluation of their models with observations. And it takes time, actually, because like you're kind of taking people out of their comfort zone, if you like, and I see this as another layer to that, where if people are all, taking all these different, say, machine learning tools that maybe aren't appropriate or don't give uncertainty estimates, and some do and some don't. Again, it's like, I think it's coming back to that critical thinking of like, if we're doing science, we need error bars. Right? I don't think it's science if we don't have uncertainty estimates, and I feel really, really strongly about that. But it actually can take quite a while to bring people away from this kind of, the physical model is the truth, the machine learning is the truth, and like to undo that thinking and get people to be more critical and skeptical of these methods, while still thinking that physics models are really good and machine learning models and AI is really good. You can hold both. You can think these things are incredibly powerful tools while still being critical, but I would say it does take some time if people have got very wedded to the particular tool. Yeah.
I mean, just to add to that, in defense of AI, the beauty of it is that it's learning. So even though it wasn't the case previously, it can learn about where trends are going and start predicting better and better. So in my own family, we have one key application of AI. My daughter has diabetes. She has a sensor now that measures what her blood sugars are, and that's connected to a pump that gives her insulin. When she first got it, we were highly disappointed. It wasn't really a closed loop, it wasn't working that well. But it has learned. It has learned about her behavior, it knows what is happening, and because of that, the model is now much better. It also makes us then a little bit asleep at the wheel, because computer does it now. Sometimes she does something out of the ordinary, and then, or the body does what the body does, and you never really know. And then we still have to do something about it, and we tend to forget that. In her case, she becomes very moody then, and we just think she's a bad teenager. Turns out that low blood sugar, you probably all have that sometimes. Even if you don't have diabetes, you're not the best person you can be. So that is a little bit the beauty of it as well. And there you can see a very concrete solution that is improving over time and makes, in our case, our lives much better. You had a question. And you have the microphone as well, so go for it.
Hi. whatever. I'm Sachi. I'm also a student of ESG management over here. I had a question in terms of the opportunities of AI. I just wanted to understand, not just in terms of the ESG reporting standards, but what are the kind of benefits that, we've talked a lot about the energy consumption and the water use, that's the negative impact of AI, but couldn't AI be used, or is it being used by companies to reduce the energy consumption or reduce the water use? Any examples that you could give us?
I mean, yes is the short answer, in the sense that it's obviously in their interests to do that. I mean, huge reductions, I think, really, really, really big. So, but it's that thing, isn't it, of trying to outpace the growth. We always have this as you said, Frans, every technology where we are getting more efficient with that technology, but then using it more, but then getting more efficient, but then using it more, and it's about the rate.
Yeah, I think so. If you look at the big numbers of emissions in say the British economy, then it would be the power system broadly, transport and buildings. So and certainly in the power system, more and more AI is obviously being used in the management of networks, and power networks are becoming far more complicated because they're becoming two-way, because we're all becoming producers because we've got PV cells on our roofs, whereas in the past it used to be a big coal-fired power station. It was one way, now it's two-way. So managing these networks and doing a lot of trade across, quite variable inputs across European networks is so much more complicated, and it's fine-tuned. And AI is absolutely fundamental to the management of those systems and will be in the future. So that's a completely fundamental part of our ability to adopt more and more renewables into, say, zero carbon electricity generating technologies. I think also in terms of buildings, it would be very important. So, for instance, for King's, we now have a digital. We operate about 150 buildings in central London on the 5 campuses. We consume huge amounts of gas mainly to heat them up. I think the heaters are probably not on today, but they may be. And that is actually the largest emission that we have as a university is in heating our buildings. We have a digital twin now of our whole estate. And the intention is very much to begin to use that digital twin now to manage energy consumption, lighting systems and so on, increasingly with more tech embedded in with sensors and so on in rooms, so that as this room is becoming a bit warmer because there are more of us in here, it would be sensitive to that, and an algorithm would switch us off, in this space. I think as time goes on, that will inevitably, incrementally bring down energy consumption in our buildings, and that will be a big number because the emissions associated with that will be important. And as we begin to convert away from gas boilers in the basement to heat pumps on the roof and elsewhere, we'll have to manage these systems which are increasingly complex to deliver the comfort that we need in these buildings. So, no, absolutely, AI is absolutely central to managing the complexity and the sensing that's going on with these buildings in order to optimise and reduce energy use and therefore emissions. So yes, fundamental to those changes. Yeah.
Question in the back.
Hi, I'm Kavita. I'm doing a PhD. I also work in sustainability impact. And I have a question regarding AI and research. So what they say in pharmaceuticals and in chemicals and in various other research levels is that AI will increase the speed of combinations that one can research. Where a researcher might spend 2 years trying to find different combinations, AI using either a digital twin or other such technology will do it faster. How viable do you think that is? I mean, and what is this interaction between research, like high-level research in compounds, materials, chemicals, and all such areas which most of the time we said sustainability was not possible because we can't replace it with the right material or it doesn't have the right properties and so on. And now we're being told AI can do that faster. Is that true? And if so, where and how?
Well, I mean, that is very much true. It's almost the flip side of what I was talking about before. So you're talking about inventing new materials and invention of new chemicals and new drugs, for example. And I was talking about the safeguarders. We were both talking about the bioactivity of them. So you can predict, and it is widely used. The pharmaceutical industry does it on mass scale at the moment. You can predict. So you can run a drug screen and look at cells and how they are changing in their features, and you can use that based on the structure of the chemical library, which might be many thousands of molecules, and it is used to be able to deduce what type of structure of molecule will have some kind of effects that is desirable in this case. So again, it's the very same principles as basically quantitative structure activity analysis that you do, and in one case it's that you're looking for desirable structures, in the other case it's that you're looking for undesirable structures. So, yeah, very much.
Chair? The microphone is next to you, but he doesn't realize that.
Thanks very much. Kartik, Project Change Manager at King's. I've got two questions, one for the panel and one for Luke. For Luke first, do you worry that too many controls are already being put in place that may jeopardize AI innovation? And for the panel, as most resources are currently remaining in the hands of Big Five or Big Seven, and we're mostly universities and large organizations are still users and consumers, and we're sort of waiting for the next model to be brought out. It's good to be talking about this, but how do you see that transfer of power from them to us, so to speak, and for us to be using AI for sustainability? How do you think that would happen?
Too many controls reducing the innovation in AI. First is that many controls in the UK. It's not clear to me. I know that the US brought in the AI Act, but it's going to take a while before it's actually implemented, and also where we find ways of implementing it, because that's the challenge between having an act and then something that can be enforced. It took a long time for the GDPR to be percolated across the system, and we'll have the same challenge with the AI Act. I'm going to turn the question back, which is, well, are there enough controls? And this race towards building larger and larger models without really thinking about what we are doing is also a real concern. So at the moment, I don't think innovation is hindered by anything. It's still going full stream, and we need to be more careful about what we do. And it's not straightforward to act and find the right ways of managing that, whether it's from a safety point of view or whether it's from a sustainability point of view. It's unclear how we should do that. And as Frans was saying earlier, it takes a lot of time for technology to mature and be regulated, and we can't do that overnight.
And the second part of the question, if anyone remembers.
I can give a quick answer. I mean, I kind of already said it about operational weather forecasting. I sort of hope in a lot of these cases that those corporations might just effectively get bored of it and hand over and make things open. What I hope doesn't happen is that they have some disaster, like not predicting an extreme weather event or something that causes them to drop it like a hot potato.
Hello, my name is Soumya. I'm a master's student in AI. I was wondering, as it is with climate change having larger impacts on global south, do you feel that the concentration of AI technology in a few countries will have similar impact in the global south? And if yes, how can we mitigate that, or how do we overcome that? Thank you.
A very interesting question.
Yeah.
Who wants to give that?
Gosh, I don't know. It's a really interesting question. I don't quite know that I have an answer. I think, you know, with new technologies, and this was alluded to in the earlier question as well, you do typically have a concentration in the hands of a few innovators and you know, technology holders. And they can extract huge power and economic rents from that position. That would be typical for any, you know, any technological field that's novel. I think what will tend to happen with AI is that these tools become, you know, cheaper and more broadly understood and applicable quite quickly. Actually, it's not like the development of pharmaceuticals and where the barriers to entry have remained very high. I suspect that the application of many of these tools will become much more generalised, and that's certainly what the big platform companies are anticipating as well. So you'll get a rapid fall in the cost of doing this kind of thing, and therefore it will be more widely disseminated more quickly. That is also the only way in which these technologies can have pervasive and transformative effects, I think. I think if these technologies remain in the hands of a few who extract monopoly rents as a result, and you know, actually the capacity for those technologies actually to have widespread pervasive effects in economies and societies will be much more limited. So I think there's always a trade-off there. I suppose, you know, if I have an answer to the earlier question, the trick for people like us will be not to become too dependent on certain technology providers. I mean, you know, we know how the physics works in climate models. We'll continue to refine our understanding of how raindrops form in clouds, which is still one of the great mysteries in climate models. Let's continue to do that. And you know, if DeepMind is willing to give us a climate model for 50 euros at the end of this process, then we'll be willing to buy. But otherwise, we should just continue to not be too dependent on these technologies. Now, obviously, that's a simple thing to say, but I suspect that what you'll have is the general diffusion of these technologies and the widespread uptake. And I suppose that's my answer to you, is that there will be research institutes in Asia and Africa and Latin America that are very soon able, at an affordable price, to apply and develop these tools. That would be my expectation.
Just a very quick addition, and actually it's a great point about the physics, because these weather models certainly rely on the physics. When I said that it was trained on 45 years of weather data, actually it's a climate model that's been nudged by weather data, and they can't yet work on observations alone. If you think about future climate change, that involves physics, because it's a different climate state to the training data, right? It's under new emissions and concentrations. So I think they do rely on us for the sort of truthing, right, and the trust of this stuff. And you know, basically, you still need physics, luckily.
I'll say something really quickly. Yeah, so I mean, so far we've been talking about the really big monopolies and really big data and these things, but AI is not only that. You can do AI on your laptop, right? And I think that AI will help in things like systems optimization and in you know, everything that's needed that actually will be making poorer places more capable of doing what they're doing better and cheaper and more efficiently.
There is a final question. We're running towards the end, so it's very brief, and I will allow it.
Hello, I'm Rituja. I'm also an ESG management student. So basically my question is like, sustainability, I feel it's achievable when we change in our behavior. like human behavior. And now this generation is very into the AI. And I just wanted to know like how AI can help to change the behavior of the new generation. Like, is there any basic changes in the technology? I'm not aware about it, but yeah, that's the question.
I guess that depends on how it's optimized. But that's with AI, it optimizes a decision and what is it aiming for. And so far it's optimizing it to keep us connected to the same, or in a house comfort, a lot more than energy efficiency. So this is where I'm at times worried. It makes us a little bit zombies because everything is done by itself, because that's what it's optimized for. And why is that? Already related to the previous questions, because these are big companies that are trying to make money out of it, and they try to tap into how we tick. And this is how we tick. Do we really care about climate change? Of course, the polls will show yes, our behavior shows no. So this is where I think that worry comes from, that how will it really feed into future generations? Yeah, it will make their lives more comfortable. But more comfortable is not always what is needed for sustainability, because sustainability very often means that we need to make deliberate choices. And AI is somehow doing the exact opposite of that. So sorry, I'm not very optimistic about that one. But it is, I think it's the key question about, is automating decisions helping us with behavioral change, or is it hindering us? And I think so far we don't really know yet. So on that beautiful positive note. Oh, we finished it up. Yeah, you want to really make it even uglier?
I've got
yeah,
okay. In fact, AI will be used to enforce behavior by people who monitor us, and that's not pretty.
No, yeah. Ooh, wow, we really are. Where are the sensors? So, yeah. I would like to thank the panelists for their really interesting opinions, and I don't think they know themselves if it's good, bad, or ugly. It's all of the above, so it's definitely a continuing discussion. Thank you for the very interesting questions, and I hope you've learned something. Then I'm reminded that this is a festival. That means that there are more events. So it's until Saturday. There are several different events. You can go to the website. And as any event, they would love you to tell how they're doing. So there should be a QR code behind me. Is that there? Yeah, there it is. I have been told by someone else that QR codes should not be trusted. But hey, this one we can trust. So that is the thing. We don't know where we're going and what our phone then does afterwards. So sorry to ruin this evaluation just now. No. So there are many different events. Please go into to those as well if you're interested. What I've seen so far is super interesting. So thank you very much, everyone. Fascinating what they do.